In this video, we'll be going over partition lists. So given the head of a linked list and a value x, partition is such that all of the nodes less than x comes before the nodes greater than or equal to x. We should preserve the original relative order of the nodes in each of the two partitions. So in our first example, we have the input list and we have a 3. So all of the nodes that are smaller than 3 is 1, 2, and 2 are on the left side, and all of the nodes that's greater than or equal to 3 are on the right side. We should note that we should maintain the relative order. So as we can see here, we get 4, 3, 5. So we have all 4, 3, 5 here. Let's go over the thought process. We can have two lists. One list, which we'll call L1, will keep track of the nodes that are smaller than x, or the node values that are smaller than x. Then one list, L2, will keep track of the node values that are greater than or equal to x. Then after we have found, or after we have processed all of the nodes, we can append L2 to L1. Let's go over the pseudocode. So we're going to create the following variables. First one is H1 is the sentinel head of L1, and then we have T1, which is the sentinel tail of L1, and then we have H2, the sentinel head of L2, and T2, the sentinel head, the sentinel tail of L2, and then we have our node, our current location inside the input list. Initially, it equals to head, or the head of the input list, and this one is initially going to be H2. The tail of T2 is initially H2, and also this one is initially H1. Now, while node is not equal to node, this means we still have nodes to process. We want to disconnect the current node. Before that, we want to save the next node. So we're going to create a node or a variable next and set it to node.next. Now we can set node.next to null. We want to disconnect the current node, and then we want to determine which list to append it to. So if node.val is less than x, this means we want to append it to L1. So append it to T1, the sentinel tail. So I'm going to set T1.next to node, then we set T1 to node. Else we want to append it to L2, so I'm going to set T2.next to node and set T2 to node. Now we want to move on to the next node, so we set node to next. This will allow us to process the next node on the list. Then now we want to append L2 to L1, so we set L1.next or T1.next, or the tail of the first list, to the head of the second list. So we're going to set H2.next because H2 is a sentinel head. So .next is the list which contains the nodes that are greater than or equal to x. Then we're going to return H1.next, which is the head of the resulting list. Let's go over the time and space complexity. So time complexity is O of n, where n is the number of nodes in the input list, and then we process each node once, and then space complexity is O of 1. Let's go over the code. So we're first going to create our variables, which will be our sentinels, the sentinel head and tails. So let's first create a sentinel head for L1, and then we're going to say T1 is equal to L1, H1, and then we're going to have our sentinel head for L2, and then our tail for L2, and then we can also have our current location inside the input list. Then we can have while node is not equal to null. We want to save the next node before we disconnect the current node. We're going to create a variable next and set it to node.next, and then we want to disconnect the current node. And then if node.val is less than x, we want to append it to our L1, the first list. So we'll set t1.next to node, and then we'll set t1 to node. Else we want to append it to L2, so we said t2.next equals to node and t2 is equal to node. And then we want to move forward in our traversal, so node is equal to next. Now we want to append L2 to L1, so I'm going to set t1.next to h2.next, and then we can return h1.next. Let me know if you have any questions in the comment section below.